All right, so this first one, we aren't going to need to work out or type in the calculator. All these choices are just the setup, so we'll just need to set it up. So S is the region bounded by these graphs. We've got y equals 2x and y equals 2x squared for 0 to 1. Again, I drew these ahead of time so that this wouldn't take us forever going over these. So here's the line for 2x, so linear. And then this curve right here is the parabola for 2x squared. And we're rotating it around the line y equals 3. So here's our axis of rotation. It's going to be a dx problem because it's like we just scooched the x-axis up a little bit. That allows you to even narrow down your choices, like knowing it's going to be dx, we can get rid of this one and this one because those say dy. So just right off the bat, you can narrow down your choices. All right, so let's do the setup for this. It's going to be pi r squared minus r squared dx. And actually, I think that helps you to narrow it down too, because if it doesn't follow that format, then it's not going to be right. All right, so our boundaries, we're using our x-axis. It's going to be 0 to 1. And the outer radius is the pink one. It's going to be upper graph minus lower graph. So the upper graph is 3. The lower graph is this parabola. That's the curve, which was 2x squared. So upper graph minus lower graph. So 3 minus 2x squared. And then the blue line is the inside radius. Again, upper graph minus lower graph. This one's the line, which was 2x. So 3 minus 2x. And that was it. That's all you had to do was the setup. Now be careful which choice you pick, because again, sometimes it's easy to do that, and then some of these look the same. Well, it's not going to be C. Let me see. So A for that one. And all I did was reverse these. So I was, A and B were really similar there. All right, number 2, they give us this graph of these two parabolas. One is reflected and one is right side up. Let R be this region, bounded by these two functions. And we are going to revolve that around the horizontal line y equals 3. So once again, I drew this ahead of time. So here is this shape. Here's our line y equals 3. They use y equals 3 for a bunch of these. Here's our ghost shape up here, and it's going to spin around like that. So this one's actually going to be really similar to the one that we just did. And this would look like an inner tube. Like you're taking this shape that's practically round and spinning it around. It would look like a donut or like an inner tube. All right, so it's going to be pi r squared minus r squared. Again, dx for this one. It's like we just took the x-axis and scooched it up a little bit. So our boundaries, looking at our x-axis, would be -1 to 1. And you can see that on this graph that they did too. So it'll be -1 to +1. And then the outside radius is the pink one. Again, upper graph minus lower graph. So it's going to be 3 minus. And then that function, this lower one, was the x squared minus 1. That was the parabola, the right side up parabola that was just moved down one. And then the blue line is the inner radius, again, upper graph minus lower graph. So it's 3 minus the reflected parabola, which is the 1 minus x squared. Now, this problem is very heavy with the algebra. We're going to have to do a lot of distributing and combining like terms and dealing with negative signs. So you just can't be scared of that, okay? I'm going to distribute these negative signs through here first. So that'll be 3 minus x squared plus 1. So I'm going to combine the 3 and the 1, that'll be 4. So 4 minus x squared, that's being squared. And then same thing here, this would be 3 minus 1, that would be 2. And then these negatives cancel, so plus x squared, again, squared. So I just distributed the negative signs, combined the like terms. Now we're going to square each of these things. If you want to write off to the side, and notice I'm still keeping my integral. I didn't even do any calculus yet. I did not even do an antiderivative. We're still, distributing everything. If you want to write off to the side 4 minus x squared times 4 minus x squared, so you can see that, if that helps you, go ahead and do that. I've been doing that a lot for these problems. For the sake of time here, I'm just going to multiply this out. This would be 16 minus 8x squared plus x to the 4th. And then this one, we're going to subtract the whole thing. Again, it would be 2 plus x squared times 2 plus x squared. That would be 4 plus 4x squared plus x to the 4th. And then I'm going to distribute the negative sign. I'm going to just go ahead and erase and fix the symbols for this. Distributing the negative through here will give us -4 minus 4x squared minus x to the 4th. All right, and then I'm going to combine the like terms there. Like I said, this one was really heavy on the algebra. 16 minus 4 will give us 12. We have -8x squared minus 4x squared. So that's going to be minus 12x squared. And then the x to the 4ths are going to cancel. All right, so finally, I've gotten that all simplified down. Again, distributing negatives, combining like terms, squaring, multiplying all this out, combining more like terms. Now, finally, we're going to do the antiderivative. So antiderivative will be 12x minus 4x cubed. From -1 to 1, we're going to do upper boundary minus lower boundary. Come over here. Cool, and I need pi out front of those. All right, so if we plug in 1, that's going to give us 12 minus 4. And if we plug in -1, that's going to be -12 plus 4. So this would be 8 pi. And this would be, -8 pi, minus -8 pi. So plus another 8 pi, so 16 pi. You know, we had to fight for that one. There was a lot of algebra in there. And then like this one step where you do an antiderivative that's calculus. But anyway, 16 pi. Sometimes that's what you're up against and you got to fight through it. So D for that one. All right, this is another one where we just need to set it up. So that's kind of nice. Let M be the region in the first quadrant bounded by the graph of y equals 2 over pi x. That's really small. I'll write it a little bigger. 2 over pi x. So that's linear and the slope is 2 over pi. So you would go up 2 over pi, which is about 3. And then we've got y equals sine of x. So again, I drew this ahead of time. So here is the line, y equals 2 over pi x, that's linear. And then here's your graph of sine of x, which is a wave. I kept that in there. I didn't erase it so you could see the wave that is that sine graph. But this little slice in here is the area that we're talking about. So this part's linear, and then this part is the curve for sine of x. And it says we're going to rotate around the line x equals -3. So this is what we're rotating around. So I drew my ghost shape over there. So this is like a, I don't know, like a really weird frisbee that's kind of like flat on the outside of it. I don't know how well that would fly through the air. But anyway, that's what that's looking like. Like it would be flat on the outside around it, but like planted downwards. And this would be a really strange shaped thing. All right, so let's go ahead and set this up. It's going to be pi and then r squared minus r squared dy. This one's going to be a dy problem. Let me back out of there. Because it's like we took the y-axis and just scooched it over a little bit. So it's going to be a dy problem. That means I immediately need to take these equations and rearrange them. So for this one, it's 2 over pi. To cancel that out, you would multiply by pi over 2. So this would be pi over 2 times y equals x. So that's what we're going to use for that one. And this one, we did a problem like this in the homework last time. I think it was with tangent. And then we, to do inverse tangent, that's arc tangent. This one's just going to be arc sine. So arc sine of y equals x. So I went back and I solved those for x. You just have to rearrange it so it would be x equals instead of y equals. Because if it's a dy problem, the whole thing is backwards. All right, so we're going to use our y values. So looking at the y-axis, this is going to go from 0 to 1. And I think all of the choices had 0 to 1 anyway, so you almost kind of couldn't mess that up. They were all 0 to 1. All right, and then the pink line is our outer radius. This time it's right graph minus left graph. So the right graph is the line, that's this pi over 2y, minus the left graph, which is -3. So it would be minus -3, so that'll be +3. Again, it's right graph minus left graph, but it was minus -3, so that'll be +3. And then the blue line is the inner radius. That's the same thing, except now we're using that sine curve. So it's going to be arc sine of y And again, minus -3, so +3. And again, all you had to do is set it up. So you just need to pick the answer choice that looks like that, which can't be tricky because they make these all like look the same. Let's see. This one's missing a square, so it can't be that. So it doesn't have a square either. I think it's gonna be D. Yeah, D for that one. So 3 is D. All right, number 4, again, I'm going to go through this. I made this one a bonus question because this one was just really, really strange. We've got the graph of x squared plus y squared equals 1. So that's a circle centered at the origin with a radius of 1. So it's centered at 0, 0, radius of 1. We're going to rotate that around the horizontal line, y equals 3. And they really like 3. I don't know for some reason. Anyway, I drew that in. Here's our ghost shape. You're taking this circle and spinning it around. So this again is like an inner tube. You're taking that circle and rotating it. So the 3-dimensional shape you get is literally like a donut. You took something that's as a circle and spun it around. All right, and then they give you this, it is known that, so that's gonna be something we use at some point. Let's go ahead and get this set up though. It's gonna be pi r squared minus r squared dx. It is dx because it's like we just took the x-axis and moved it up a little bit. So dx problem, x values for the boundaries, so it'll be -1 to 1. And the pink line is our outer radius. It's upper graph minus lower graph. Now here's where we run into a snag. We need for this to be y equals. So I'm gonna have to go ahead and rearrange this. And we did one really similar to this. We did the cross sections. Remember we had all those cross sections that were like rectangles or triangles or semicircles. We did one like this in those notes. We have to get y by itself. So I'm going to subtract over the x squared. And then we're going to square root. So you get the positive and the negative square root. The upper half, like the top of the circle, this semicircle is the positive square root. And then the part underneath the lower semicircle, that's the negative square root. So we have the plus and the minus. So the pink line is the outer radius, upper graph minus lower graph. The upper graph is 3 minus the lower graph, which is the negative square root. So this would be minus negative square root of stuff. So those negatives are going to cancel and it will look like that. The blue line is the inner radius, again, upper graph minus lower graph. So it's going to be 3 minus the positive square root. So 3 minus square root 1 minus x squared. All right, so that's set up. And then we've got, again, a lot of really tedious algebra to get through on this one. So buckle up. All right, so squaring this, 3 times 3 would be 9. Outsides would give you 3 of these square roots. Insides would give you 3 of these square roots. So total we have 6 of them. And then square root of 1 minus x squared is, the square root and the squared are going to cancel. So it'll just be plus 1 minus x squared. So that is multiplying out this first part minus parenthesis. And now we're going to do the same thing with this one. So again, 3 times 3 is 9. We'll have minus 6 square root of this stuff. And then it will be plus the 1 minus x squared. Again, negatives would cancel, so it'll be plus, and the square root and the squared cancel as well. All right, then we're going to distribute the negative. Again, I'm just going to erase here and fix this. Everything's going to flip-flop its signs. So we'll have minus 9 plus 6 square root of stuff, minus 1, and then plus x squared. Someone's asking where the 6 came from. So if you multiply this out twice, if you write off to the side 3 plus square root of stuff and then 3 plus square root of stuff, you need it twice because we're squaring it. The outsides would give you 3 square root of all of that. And then the insides would give you 3 square root of all of that. So total, it would be 6. So that's how you end up with the 6 there. Now, goodness gracious, this is a lot. So again, that's why I made this a bonus question. But here's where this actually gets a little bit better because most of this is going to cancel out. The 9s are going to cancel. And the plus 1 and minus 1 is going to cancel. and the x squareds are going to cancel. So like almost the whole thing canceled out. So it was really awful for a second, but then most of this is gone. We have 6 plus 6, which would be 12. So 12 square root 1 minus x squared. Now remember that weird piece of information they gave us up here? Here's where this comes in. You know what, let me take the 12 and put it outside. I'm going to evict that from the problem real quick. If it's a coefficient, you can take it and just put it outside. The integral from -1 to 1, which is what we've got, of square root of 1 minus x squared dx, they're telling us all of this is equal to pi over 2. So we end up with 12 pi times pi over 2. 12 divided by 2 would be 6, and pi times pi is pi squared. So your final answer to the whole thing is 6 pi squared. If you got through that, nice job. That was a crazy problem. It ended up not so bad because stuff canceled, but it was just really wicked with the square roots. You had to split this into the positive square root and the negative square root. So that was just really nasty. So again, I made that one a bit nice. All right, number 5, they give you this like flower petal leaf kind of thing. Let M be the region in the first quadrant bounded by the graphs of y equals sine of pi x over 2. Let me just write these a little bit bigger. And then y equals x squared. So we need to know which one is which. This is going to be the sine graph, and then the squared is, you know, a parabola. So starting at 0 and then being a parabola shape. So the upper graph is the sine one, the lower graph is the x squared. What is the volume generated when we spin this around the line x equals 2? So again, I drew this ahead of time. Here's that flower petal shape. Here's our vertical line x equals 2. This is going to be a dy problem because it's like we took the y-axis and just scooted it over a little bit. So as soon as you realize it's dy, you have to go and rearrange these equations. This one's not going to be so bad. You would just square root. We would do square root of y for that one. This one, we're going to have to anti-sine. So it's going to be arc sine of y equals pi over 2x. And then you have to cancel out the pi over 2. You would have to multiply both sides by 2 over pi. So it's 2 over pi arc sine of y. So you have to stop what you're doing, rearrange those, and then we can set this up. It'll be pi r squared minus r squared dy. I have a feeling I didn't leave enough space. I'm not going to be able to fit arc sine in there. I'll just have to write really little. Right, the pink line is the outer radius. It's right graph minus left graph. So this axis of rotation is x equals 2. So it's going to be 2 minus the sine curve, and it's going to be arc sine. So 2 minus 2 over pi arc sine of y. Sorry, I didn't draw big enough parentheses there. And then the blue line is the inner radius. It's going to be 2 minus the parabola curve, which we rearranged as square root of y. So 2 minus square root of y. Now these ones are all decimals. We're going to get to just type this in the calculator. Oh, wait, I need boundaries though. Hold on. Boundaries are going to be y values. So looking at your y-axis, this is going to go from 0 to 1. All right, and I know all of this says y, but we're still going to type x. You have an X button, so just use that. The calculator will never know. All right, so pi integral, what was it, 0 to 1? And then parenthesis, 2 minus, then we need a fraction, 2 over pi. That says arc sine. On your calculator, it doesn't say arc, it says sine with the little -1 in there. So you're going to hit second sine of x. Again, I know it says y, we're going to type x. Close that original parenthesis squared. So 2 minus 2 over pi arc sine of x squared minus, and now I'm on this part, so start new parenthesis, 2 minus square root of x, close parenthesis, squared dx, and it will give us the answer. Eventually. This was a complicated one. There we go. 2.835. Now they round up, So it'll be 2.836. And so that one is D. All right, last one. And all we have to do is set this one up. All right, let M be the region in the first quadrant bounded above by the graph of y equals 3x and below by the graph of y equals x squared. So we're going to draw it ahead of time. This line is our y equals 3x. And then this curve is the parabola x squared. We're going to spin this around x equals -3. And so it is going to be a dy problem. So b pi r squared minus r squared dy. It's like you took the y-axis and just moved it over a bit. So what I need to do is rearrange these. Now these ones aren't as bad. Y equals 3x. You just need to divide over the 3. So this would be 1/3 y equals x. And this one you would just need to square root. So square root of y equals x. So thank goodness those weren't as complicated to rearrange. Our boundaries are going to be y values. So looking at your y-axis, this is going to go from 0 to 9. The pink line is our outside radius. So it's right graph minus left graph. So the right graph is this curve, the parabola one, that's square root of y, minus the left graph, which is -3. So it's minus -3, so +3. And then the blue line, we're going to do the same thing, except we're using the line. That's going to be the 1/3 y. And then minus -3, so +3. And so we just need to pick which one that is. So let's see, we got pi integral 0 to 9. Okay, they all say 0 to 9. That's cool. This one's missing a squared, so it can't be that. This one doesn't even have 2 different parentheses there. I think it's going to be D. Yeah, D for that.